Okay, here's a 5-pointer from October 1994 under the category Inequalities in Absolute Value. On a number line, the coordinate of point A is 4x minus 5, and the coordinate of point B is 8 minus 2x. We need to find all positive values of x so that the distance between A and B is at least 6. So first let's draw A and B on a number line. The distance between A and B would just be A minus B. But what if B is greater than A? Then A minus B would be negative, but this distance always has to be positive. So to fix that, we just put an absolute value around A minus B. So that's the equation for the distance between A and B, and we want this to be greater than or equal to 6. So let's substitute in the values for x. A is 4x minus 5, and B is 8 minus 2x. And simplify this to get 6x minus 13 is greater than or equal to 6. So, to see how this is possible, let's let y equal 6x minus 13. So, the absolute value of y has to be greater than or equal to 6. So, let's see if y is greater than 0, greater than or equal to. Then you'd have y by itself is greater than or equal to 6. But if y is negative or less than or equal to 0, then negative y has to be greater than or equal to 6. Because the absolute value will switch its sign from negative to positive, and this part has to be positive. So that's how we get that solution. And let's use x as our variable again. So 6x minus 13 is greater than or equal to 6. And this automatically meets the condition that it's greater than or equal to 0. Or 6x minus 13 is less than or equal to negative 6. Actually, let's rewrite that so I can properly derive it. Or negative 6x minus 13 is greater than or equal to 6. And then we can write this as 6x minus 13 is less than or equal to negative 6 using laws of inequalities. And if 6x is minus 13 is less than or equal to negative 6, then it's automatically less than or equal to 0. So now that we have these two equations, we just have to simplify them. So first let's simplify the top equation. So that's one part of the solution, x is greater than or equal to 19 over 6. And the second part of the solution is 6x is less than or equal to 7, and x is less than or equal to 7/6. So those so far are what we have, and you'd think that this would be our final answer, but if you look at the initial question, it tells us to find all positive values of x such that that is true. So another criteria is that x has to be greater than 0. So one step that's nice to take here is plotting all our values of x so far. So this will be 0 on the number line, this will be 7/6, and this will be 19 over 6. So x has to be greater than or equal to 0, but less than or equal to 7/6. And it can also be greater than or equal to 19 over 6. And let's turn this back into equation form. Six or x is less than, no, it's supposed to be the other way, greater than or equal to 19 over 6. And this is our final answer.